you are going to be a geometrically awakened person by the end of the section. Trust me there. Trust me there. So we're going to prove not just one, but two triangles are congruent in all these problems here. Anyways, what I'm going to do right now with you guys here right now is classroom exercises number 1 through 4. So we had class today. We talked about a little bit of this silliness here. We're going to have a lot of triangles. Got to prove them congruent. And then we're going to use CPC-TC not just once. We're going to use it once after we prove the first set of triangles congruent. I call those the helper triangles. Okay, so we use CPC-TC after we get the congruent triangles, because that's going to help us get a pair of corresponding sides or angles, and then that's going to help us prove yet another pair of triangles are congruent. Whoa, and then we're going to use CPC-TC again. You ready? Ready to strap in with this here? So anyways, I would have liked to maybe have done some of these in class. Of course, I was just being kind of a goofball in class, and that's fine. I can do it every once in a while. But I stayed, 7th block I stayed, and I went, and we just kind of went through the first 3 problems or so, 2 problems with a couple people stayed with me. And I was like, you know what? I think I'm going to film a video. I think I'm just going to go through those classroom exercises. So anyways, let's do them together. Classroom exercise number 1, again, read the directions, figure out what you got to do here. In exercises 1 through 3, you're given a diagram that is marked with given information. So here, this whole thing is the diagram here. I see 1 triangle, 2 triangles. Oh, wait, I see a 3rd triangle. 1 triangle, 2 triangle, I see a 3rd triangle. So I see 6 triangles total in this diagram, this all-inclusive diagram right here. So that's, 6 triangles, I'm probably going to have to prove at least 1 set of triangles are congruent, if not 2, to get to ultimately what I'm trying to prove, which is going to be this. Anyways, you're given a diagram that's marked up with given information. So we have this. We know that AB is congruent to, or segment AB is congruent to segment DE. We know that AC equals DF, length AC equals DF. We know that this whole larger angle here, this is a little bit confusing the way they mark this up. We know that angle BAC is congruent to angle EDF. We know that SC, length SC is equal to length TF. Okay, so anyways, we're marked up with given information, and now we're going to prove something. Given all this given information right here, that's going to be enough to prove that AS, okay, let me mark it up here what I'm trying to prove. AS, question mark, is congruent, segment AS is congruent to segment DT. Okay, if I'm given all this information, everything that's marked up here, that's going to be enough to prove this. But we're going to have to prove it. We're going to have to use those rules and justifications to get some steps down in order to get us down. Well, why do I know that that has to equal that? Well, it freaking looks that way, doesn't it? It just does. Like, it looks like probably all these triangles, this triangle is probably congruent to that triangle, that triangle is probably congruent to that triangle. The larger triangles are probably congruent to one another, but hey, let's do it. Through a chain of reasoning, I want to establish this given all this marked up stuff, okay? So here's the key steps of the proof. If I knew all this stuff, if I said that all this stuff is givens, luckily here you don't have to write the proof, so you're just giving the key steps. So I don't have to list out my givens in this. I just need to justify some key steps in the proof. And what are the key steps going to be? Well, this whole section, the whole deal in this section here is I'm doing some double CPC-TC action. That's right. In order to use CPC-TC, you need to prove that triangles are congruent first. Okay, because remember, CPC-TC stands for corresponding parts of congruent triangles. Well, they're congruent also. So it allows you to say that certain angles are sides of congruent triangles. Well, they're congruent also. So anyways, you can't do that unless you've proven congruent triangles first. Okay, anyways, let's get to it. We want to prove, like, given everything that's marked up here, like, look here. They don't tell you that any of the triangles, any pairs of triangles are congruent. So how would we deduce that based on the diagram here? What do we got? Triangle ABC, okay? Triangle ABC, they're saying, has to be congruent to triangle DEF. And why would we know that? Why would we know that? Well, what do I see? Okay, if I'm looking at just this step right here, I'm looking at this, AB, well, side AB, ooh, that corresponds to DE. So there, I have a side. I have a side, and then angle B in the middle here, right? Or angle B over here. Wait, oh, never mind. Not angle B. Angle BAC here, right? I have an angle congruent to this angle right here. Side congruent to that side, angle congruent to that angle, and I have another side over here, side congruent to that side. In the triangle ABC and triangle DEF, looks like I have a side angle side correspondence. Side, and then their corresponding angles are congruent. It looks like that angle is included between the 2 congruent sides. So my key reason to justify why, given everything that's marked up right here, given why I know that those 2 triangles are congruent, are SAS, okay? SAS, okay? So now I got these larger triangles congruent. They're going to be my helper triangles to ultimately proving that, hey, this action right here kind of looks like a median. It's not a median. I mean, this looks shorter than that. But anyways, just that this segment here right? This segment here is going to have to be congruent to that segment there based on what's drawn up, okay? So I got my helper triangles. That triangle and that triangle are congruent. So maybe I'll actually outline those, okay? So there are parts of these triangles that I just proved are congruent that are also parts of triangles that will help us prove that segment DT and segments AS have to be congruent to one another. Why? Well, look, that segment here is part of this triangle right here. This segment here is part of this triangle right here. And I know that this triangle right here, for instance, that is also part of the blue triangle, the bigger one here. So I know that angle F, okay, here, I'm going to mark it out because that's what they do next. Angle F has to be congruent to angle C. Okay, and why do I know that? Well, triangle ABC is congruent to triangle DEF. And I know that corresponding parts of congruent triangles, and these are indeed corresponding parts, and these triangles we proved are congruent already, we know that they're congruent to each other. Corresponding parts of congruent triangles are congruent to one another, CPCTC. So that's it. That's the reason here for step 2 here, okay? Prove the triangles are congruent. What follows from that, all their corresponding angles, all their corresponding sides are congruent. So we just need to say CP to C as their justification, okay? Now that I know this, I'll maybe switch colors, right? Too close for missiles, switch into guns here. That was a reference to Top Gun, sorry. It's kind of insensitive, not in this day and age here, so I take that back here. Please forgive me for referencing an 80s movie. But anywho, we're going to switch to Triangle ACS. Tom Cruise, right? Tom Cruise. Yeah, great soundtrack. The Eye of the Tiger is in that here. Tom Cruise, 80s films, flying around jets. Tom Cruise was actually just in San Francisco for Fleet Week, as a matter of fact. Top Gun 2 coming out to us at some point in the next year. Anyways, Triangle ACS. So now we want to change the colors here because I want to then say, like, once I get this angle congruent to that angle, I can say that this triangle has to be congruent to this triangle. Why? Do you see it? I hope you see it right here. Look, SAS. Look, those sides are congruent to one another. This angle is congruent to that angle. It's included SAS. So this one's also SAS here. You got SAS to prove both of those triangles congruent. You got this set of triangles congruent. CPCTC helped you. I needed that. Look, I needed angle C and angle F to be congruent in order to get that SAS thing going here. So now I can say through CPCTC, I know that that side of the yellow triangle, because I just proved the triangle's congruent, its corresponding side over here also has to be congruent. Why? By CPCTC. That's right. So AS, and I see AS. I see AS right here. I see DT. So that's going to tell me that they're in corresponding places. So I know that if I know triangle ACS is congruent to triangle DFT, I don't even need the freaking diagram because I know that A and S, D and T, those correspond to one another. So I know that segment AS is congruent to segment DT. Okay, so that's all you need to write for your answers down there. Number 1, SAS, CPCTC, SAS, CPCTC. Okay, let's do. So it's really slow watching the first examples. I go slowly first examples. Teachers should go slowly first examples and then go a little bit faster as you've seen more. So let's do the rest of them kind of faster here. Okay, what do I got to prove? I want to prove that AX. Okay, so I'll mark up 3 tick marks here. I want to prove that is, given the diagram, given what I have, AX is congruent to AY. Okay, and how we do that? Well, I see this. Okay, so it looks like I have this. Looks like the way I'm seeing it, where I'm going here, this triangle I can prove is congruent to this triangle. Okay, and you don't have to prove these without, kind of having the steps already written down for you. This will probably be mostly on your problem set on Friday. But anyways, I can prove that blue triangle, this large guy, is congruent to that large guy. Why? What's the reason? Well, I got vertical angles, right? I got vertical angles right there. Angle NAK is a vertical angle with angle PAL. And what do we know about vertical angles? Vertical angles are congruent, right? That was a theorem from, I think, section 1.6. Vertical angles are congruent. We're still using it here. So here I have a side angle side, right? These sides corresponds, the angles included, it corresponds, and they're congruent. And then these corresponding sides are also congruent. So this is also SAS. Give me an S, give me an A, give me an S. So anyways, a lot of SAS in this problem set so far. That's going to change in a second here, only because I've done this problem already. Angle L is congruent to angle N. How would I know that? How can I justify that? Well, I got a triangle here. I got another triangle here. What do I know about those 2 triangles? Well, in step A, I proved that they were congruent by SAS. So if there are 2 triangles congruent, I know their corresponding parts are congruent. So you guessed it, CPCTC, right? Why are you going to see CPCTC once? We're going to say it twice, double CPCTC. Oh my goodness. Stay geometrically awakened. Anyways, so CPCTC says that part of this triangle is congruent to its corresponding part over there. So sure, I can say angle L is congruent to angle N. And that's going to allow me to then, well, prove where they're going with this. Well, you'll see in a second. I'm not even looking to see what triangles. I mean, the reason why I say CPCTC there, your strategy is because I'm trying to get this angle congruent to, this triangle congruent to that triangle. And that's good. That'll get my job done. If I can get that triangle congruent to that triangle, then the side, this segment here and this segment here, they're corresponding sides of those triangles. So I'll be able to get the things I'm trying to prove, which is this. I'll be able to get it proven, okay? All right, so to get those triangles, how can I justify that? How can I get that here? Well, I have vertical angles, nice. I have that. I have a side here. Ooh, I have an angle here. So this is actually going to be angle. Okay, those angles correspond. Sides, this side corresponds to this side, and they're congruent, right? So they're given to you as congruent. And then I have, this guy right here, two tick marks. Yep, I got those vertical angles are congruent. So here, this one's going to be ASA. ASA. That's how I prove it. Notice here, you're just giving reasons for the key steps of the proof. So if you're actually proving this one, you'd have to say that angle is congruent to that angle by vertical angles congruent. Here, right? How you get the triangles congruent? Well, eventually, I get vertical angles congruent. We got angles correspond. Sides already correspond because they're given. CPCTC got us those corresponding angles. So anyways, ASA. We're putting down that as the answer. And so then the nicest thing is all these D's, the answers to all the D's should be what? Should be what? Should be CPCTC. That's right, CPCTC. CPCTC, we got it because AX and AY, look, AX and AY are corresponding sides of congruent triangles. So we know that corresponding parts of congruent triangles are congruent. Congruent, yes, of course. Oh, it's a good time. Yeah, why would I do this job if I can't enjoy it here? Anyway, prove this. This is the next one here. Go a little bit faster here. Angle 3 is congruent to angle 4. Let me go ahead and put question marks down to it. I'm trying to get those two congruent here. I can't do that yet because I don't have enough information to prove that triangle is congruent to that triangle. I don't know. I just got a few congruent sides to one another. I don't even have enough to prove that that triangle here is congruent to that triangle right here. It's just I have the one side. I have the one side. So where are my helper triangles, right? We want to figure out, we want to use some helper triangles that we can prove them congruent, then say one of their pairs of corresponding parts are congruent to then help us get the triangles. Because the way I would get angles 3 and angle 4 congruent is that triangle congruent to that triangle, or this larger triangle congruent to this larger triangle. Why? Well, angles 3 and angles 4 are angles of those two different triangles. Here, your helper triangles are over here. If you haven't seen it yet, your helper triangles are right here. You just get good at diagram recognition and working with diagrams here in geometry. That's the name of the game here. I can get those two triangles congruent. How can I do that? Well, you've been doing it all along, right? Check it out here. We share a side right there, right? BO is part of both triangle BOL and triangle BOJ. OJ and OL are given to you as congruent. BL and BJ are given to you as congruent. Here you'd have to say reflexive, but what do we have? We have what type of a postulate or theorem can we use? What type of a correspondence? That's right, S. That's right, heck yeah. And now it's time to stay geometrically awake, shouldn't we? Angle 1 is congruent to angle 2. Well, I know that because of CPCTC. In the previous step, I just proved triangles congruent, so then I can say their corresponding parts are congruent, or the corresponding parts I care about. And I cared about getting angle 1 congruent to angle 2. Why? Well, now I have, what do I do? What do I do in this one? Oh, okay, I see it now. It's one a little bit harder to see here, but check it out here. This is also going to be S, okay, because BJ and BL correspond here. Now I got angle 1 and angle 2. That correspond, they're congruent right here. Corresponding parts are congruent. So now I have an S congruence, I have an A congruence, and then finally I have the other side of the angle, right? I have SA and then S. BA is equal to BA. They're not showing it to you here, and that's by reflexive. So I have a side of this triangle BAJ, look, BAJ or JBA, and this triangle here, LBA. I have the sides given to me, the angles I just proved, and look, they share this large triangle, right? We're talking now using that to get the large triangle. That large triangle right there, and this large triangle right here. Okay, we're given those sides, we just proved the angles, and then BA equals BA by reflexive. So what do I have there? I have SA, and well, that's S. Okay, so SAS for that guy right there. And then part D, nice and easy. What can I put for my justification? Give me a C. Give me a B. Give me a C. Give me a T. Is that right? CPCTC. Yes, it is. Okay, right? Make some friends in college there. Don't get CPCTC wrong when you're bumping into 20-year-olds and you're just remembering how young and carefree your life used to be at age 14. 15. Anyways here. All right, let's check it out here. State a plan for proving that angle D is congruent to angle F. This is the last classroom exercise. You just got to do, I think, 6 written exercises or 7 written exercises after this. Anyways, check it out here. How would I get angle D congruent to angle F? Well, let's check it out. Well, these are not going to be my helper triangles. I got a lot of triangles. So I got to find helper triangles. What are some triangles I can prove are congruent pretty easily? Well, I got vertical angles here. That might help me. Ah, yes, I see it. You see it? Let's do it together here. Well, you see vertical angles, you want to mark up vertical angles. Guys, I have fun with this because, I don't do proofs like this. Like, well, I only do them a few times a year, right? Like over the summer, I'm not doing these things. I get to them like, yes, yeah, good times. Let's find some congruent triangles. All right, I marked up vertical angles. What do you notice? Who's going to see it first? All right, the vertical angles are congruent here. Maybe you find it. These triangles. Check it out. I've been doing this a while here, since I'm faster at finding congruent triangles. I found this triangle here has got to be congruent to that triangle right there. Why? Who sees it? Not HL. Nope, not HL. Well, this is a right angle. That's a right angle. So they're congruent to one another. They both measure 90 degrees. So I got A. I got A, S. Well, so it's A is the right angle, and then right angle, go to the vertical angle, and then the side here. So the angle is not included. The side is not included here. The side's kind of off on its own. It touches that angle, but this angle has nothing to do with that side. So the side is not included. So that's why this is going to be AAS and not ASA. Okay, so what I would say here is first, I would prove triangle EPC congruence to triangle EQG by AAS. Then, so those are my helper triangles. How are they going to help me get to angle D being congruent to angle F? Well, I have DC congruent to GF. I know that this is a right angle. Ooh, don't forget about that. If it's a right angle on this side, it's a right angle on that side here. Because remember, perpendicular lines create 4 right angles. And so we have a right angle there, right angle there, right angle there, right angle there, if we extended line CP. So I have a right angle. So I'm trying to prove that angle here. Well, I can get this triangle congruent to that triangle. Okay, so then how are we going to do that? I would prove triangle PCD congruent to triangle QGF by what reason? Let's see if we can find the reason here. Well, they're both right triangles, so it could be HL. I got the hypotenuse. Yeah, the hypotenuse here, that's the side opposite the right angle. Side opposite the right angle, hypotenuse. The hypotenuses are congruent. That's given to us, so it might be HL. Can we find a leg? Yeah, we can. I'm going to erase this here because it's going to be, we can find that leg right there. Why? Well, I just proved that those 2 triangles in purple are congruent. So I know then so I got to say this first, then through CPCTC, I would state that CP had to be congruent to GQ. Okay? Because CP, GQ are corresponding. And then I would say, so then I can prove, this is like one long sentence. I probably should have some periods here. First, I would prove this by AS. Period. Okay, let's make that period. Then through CPCTC, I would state that. Okay? So then I can prove triangle PCD congruent to triangle QGF by HL. Okay, by HL. Okay, and then I can say at the end, therefore, angle D is congruent to angle F by, you guessed it, C. That's right. I said CPCTC how many times here? I said it once after I proved the first set of triangles congruent. I said it second time after the second pair of triangles congruent. Double CTCTC. You're saying that pretty much twice in every single problem you have today. Message me if you have any questions. I had fun with this. Hooray! Happy Wednesday night for me. Take care, guys. Bye.